When we talk about black holes, we often focus on the gravitational pull, the immense density, or the event horizon. But there's another aspect, one that's just as fascinating and perhaps more unsettling: the way black holes affect time. Time, to most of us, feels steady. We measure it in seconds, minutes, hours. It ticks by evenly, no matter what we're doing. But that's an illusion. Time is flexible. It stretches and compresses depending on gravity and motion, a consequence of Einstein's theory of relativity. And black holes? They are the ultimate time manipulators. Imagine floating far away from a black hole, watching someone fall toward it. To you, from a distance, their motion appears to slow down as they approach the event horizon. Their descent becomes sluggish. You see them fade, redshift, dim, and then stop, just hanging there at the edge, frozen in time. But from their point of view, for the person falling, time feels normal. They pass the event horizon without noticing anything unusual. They fall, and time flows forward as always. Two different experiences, both valid, both real. This isn't a trick, it's physics. This strange disconnect is due to gravitational time dilation, the phenomenon where time passes more slowly in stronger gravitational fields. Near a black hole, gravity is so extreme that time nearly halts from an outside perspective. If you could hover just outside the event horizon, minutes for you might mean centuries for the universe outside. A minute spent close to a black hole could be an eternity out there. It's a concept explored in science fiction, most notably in Interstellar, where astronauts visit a planet near a supermassive black hole and return to find decades have passed for others. But this isn't just fiction. It's based on real calculations. It's real physics. And this time, distortion doesn't just apply to human observers. It affects light. As photons climb out of a black hole's gravity well, they lose energy. Their frequency lowers. Their color shifts redder. Eventually, they become invisible, stretched out into wavelengths too long to detect. That's why black holes are black. Not because they consume light instantly, but because they trap it so deeply in their gravitational grip that it cannot return in a recognizable form. But go back to the person falling in. As they cross the event horizon, they can't see the outside universe as it was. Instead, it would seem to speed up. The entire future of the universe might flash before them in an instant. Stars aging, galaxies drifting, even the end of time itself. It's speculative, of course. No one has experienced it. No data has returned. But based on the math, based on general relativity, this is the implication. And that brings us to a haunting idea. What if someone fell into a black hole and survived? Not the singularity. We don't believe anything survives that. But what about before that, during the descent? Could they live for a time? Experience things? Observe? Surprisingly, yes, at least for supermassive black holes. You see, the tidal forces, the stretching effect of gravity, are much gentler in large black holes. In a stellar mass black hole, you'd be torn apart long before reaching the horizon. But in a black hole with millions of solar masses, the event horizon is so vast that the gravitational gradient across your body is small. You wouldn't feel a jolt, no sudden crunch. You'd fall calmly, peacefully. It's sometimes called the gentle death. Not because you survive forever, but because you wouldn't notice the moment you crossed the boundary. You'd simply keep falling, with time behaving strangely around you. There's something profoundly poetic about that. The idea that the universe contains places where time becomes fluid, where direction breaks down, where future and past blur into something unknowable. And it's not just black holes that warp time. Anywhere there is gravity, there is time dilation. We've measured it on Earth, with atomic clocks on mountains ticking slightly faster than those at sea level. We correct for it in GPS satellites, which would drift if we didn't account for time bending slightly in orbit. Black holes are just the most extreme version of something that's happening all the time, all around us. They remind us that time isn't a constant drumbeat. It's a thread that curves, twists, and sometimes snaps. And if that thread can be stretched near a black hole, what does it mean for the future of time itself? Could we one day harness gravity to slow time, to preserve life, technology, even consciousness? Or are we simply passengers in time's current, flowing toward the unknown? For now, we don't have the tools to travel close to black holes. But our thoughts can. Our questions can, and in thinking about time distortion, about falling forever, we start to feel how strange and how wondrous reality truly is. So tonight, let time move slowly. Let questions stretch and echo like starlight near the edge of the abyss. Because sometimes the best journeys are the ones that happen without movement at all. Just you and time and the silent pull of something far beyond.